For any further questions, maybe you can tackle them at tea time. Thanks, Puti. Our next presenter is going to be Nontembeko Dube from ARC. She's going to be talking to us around the biology, host specificity of a potential biocontrol. Just a reminder to you, Nontembeko and the others, these are not part of the audience. When I flash these, it means the time is ticking out.
Okay, thank you. My work was done with the overseer of Dr. Kostas Zakariadis and Maki Huitwa. Unfortunately, they're not here to share the responsibilities, like answering questions, but my chairperson can help. He's got some background on biocontrol. Okay. We all know that invasive alien plants pose threats to our biodiversity, including national parks. And among these, Chromolaena odorata is the worst in KwaZulu-Natal, and it is known to make game viewing virtually impossible in Umfolozi Park. Hence, it has been a good target for biological control, which is the use of natural enemies such as insects and pathogens to suppress pest population or weeds. Hence, several biocontrol agents have been considered for control of Chromolaena in South Africa, especially those that have been successful in controlling it in other parts of the world. However, many of them failed to establish, were rejected because of lack of host specificity, and some failed to establish in South Africa because the biotype of Chromolaena invading South Africa is different to the biotype that invades other parts of the world. So far, only two biological control agents have managed to establish. Those are Parakeetus insulata, a moth with leaf defoliating larvae, and Calicomyza, a fly with leaf mining larvae. However, these two have not managed to control Chromolaena into adequate levels. Hence, last year, in the beginning of last year, we released third agent, Lixus aemulus, a weevil with stem-boring larvae. However, this agent is slow to breed, and no establishment monitoring work has been conducted so far. So, currently in the laboratory, we're examining the Dichrorampha odorata, which is a new described species by Brown and Zakariadis. Okay, I'm hearing some mumbling like that. There are already 3 agents out. So why this one? Why the Dichrorampha? Okay, as we've seen above, there are no shoot tip attackers yet that have been released on Chromolaena. So this agent attacks the shoot tip, and it is hoped to decrease the growth rate of stems. Hence, it will promote branching and make the plant to be less competitive and reduce flowering. And that agent, the Dichrorampha, it was collected from Jamaica, which is the Caribbean island, and our form of Chromolaena is believed to be from the Caribbean islands. So we're not expecting to encounter biotype compatibility problems like we've done before. We hope it is going to establish along the coast and further inland. It is easy to rear, and it has got short life cycle. Okay, so the aims of my study was to determine efficacy of the Dichrorampha odorata as the biological control agent of Chromolaena. This was done by determining its biology and host specificity screening and examine its impacts on Chromolaena. Okay, the parameters that were measured under biology were Dichrorampha odorata adult longevity, fertility, longevity, and larval developmental stages. Remember, I said it's a newly described species, so no much is known about it. So under host range screening, we looked at the larval boring on Chromolaena, and the intensity of damage was also looked and categorizes into 3, and then the survival rates of larvae to adulthood. And on efficacy of Dichrorampha, we measured the stem diameter at pot height and the following parameters. Okay, so what we found is that Dichrorampha, a single female, lays about 15.4 number of eggs, which hatch in 10 days, and 96% of those eggs hatch and then pupate in between 20 to 23 days, and the adults eclose after 11 to 12 days and live for in between the range of 2 to 7 days. Okay, we found also that the Dichrorampha is having 5 instar larvae. That's all about the biology. When we looked on host specificity, what we did, I exposed about 34 plant species, including Chromolaena, which are closely related to Chromolaena. I exposed them to the Dichrorampha larvae. So what I found is that 14 of the test species were brought in by Dichrorampha and Chromolaena also. I also found that Mycenia natalensis, which is indigenous, had very high larval boring, which was frustrating, of course. When I looked at the damage of intensity, I found that it was actually very high on Chromolaena and in one replica of Stomatanthes africanus, which is also closely related and indigenous plant. However, when I looked at the survival rates of these larvae, I found that the pupation was only found on Chromolaena and the eclosion, and in all other plants there was nothing. It means they didn't sustain the development of the larvae, which was very nice. Okay. So when we looked at the efficacy of Dichrorampha, we found that there was no significant difference on shoot tips and stem diameter as expected. However, the controls had significantly higher or taller plants as compared to the treatments. And then the controls also produced more flowers compared to the treatments, which we were expecting, and that was very nice. Okay, we also didn't find a significant difference when we considered the plant biomass parameters, as not expected. So, on discussion and conclusion, the basic biology of Dichrorampha now is understood, and that can assist us in measuring plants and release techniques. You've noted that it lays very few number of eggs, like 15. However, the way it lays them is like impressive, because it doesn't lay all of them together in one part whereby an ant can come and find all of them. Instead, it lays them singly, so it won't be easily parasitized. Although larval boring was observed in 15 plant species, including Chromolaena odorata, the intense damage was only found on Chromolaena, and only Chromolaena has supported the larval development of Dichrorampha to adulthood. So we are very confident that Dichrorampha is safe for release in South Africa. And we're hoping that Dichrorampha may not reduce stem diameter or plant biomass. However, it will decrease the plant height and make it less competitive and reduce the flowering. Hence, decrease the competitiveness within surrounding vegetation, and maybe make a clear game viewing, like very possible. Yeah, that's all. Thank you.
Thank you very much. That was very engaging and promising. I'll begin with somewhere now. I don't know who's got any questions. Yeah, I know there's one from here. Okay.
So are you then putting an application for release